This tutorial is for week 11 group problem solving, solving equations. As you may have noticed, problem 1 is different from the equations in your project, and so that you can just follow my process and not just write down the answer. All right, we're supposed to solve the system of equations, and the first thing that I'm going to do over here is there's lots of different options. The first thing I think most people are afraid of is that fraction. So I'm going to show you how to get rid of it. Because the 5 is down here, the best way to get rid of it is multiply everything in this equation by the least common denominator. And since 5 is the only thing in the denominator, we can just say we're going to multiply everything in here by 5. Using the distributive property, 5 times this fraction here makes 5 times 5 divided by 5, so they cancel out, and I'm just left with 3x. I'm going to go ahead and copy and paste this so that I can show my steps. So I'm going to be moving that 5, multiply that in, and I only have 3 left here. Another way of thinking about that is 5 times 3 is 15, divided by 5 is 3, but it's faster for me just to think that they cancel. Now the 5 multiplied into the 6 gives me 30y, and 5 times the 12 makes this 60. Okay, so that's the one really fast way to make sure that we get rid of all of the fractions really quick off the bat. So on yours, you can go through and look at all the denominators and find the least common denominator and multiply it throughout, and it gets rid of the fractions. If you're not afraid of working with the fractions, then go ahead and leave it. It's just up to you and personal preference. All right, so now we have our two equations here, and we can do substitution, which is what the textbook showed. And so I'll go ahead and go through that, although in most of our problems I would actually recommend the elimination method, like the video I showed in the Mobius homework. So if you want to refer to that one as well. I'm going to go ahead and go through what the textbook shows you for substitution, and then I'm going to show this one as well using the elimination method. So the first thing I'm going to do is pick one of these equations and decide what variable I'm going to solve for. And since this one already has an x all by itself, I'm going to go ahead and solve that one for x by subtracting 10y over. So I'm going to copy and paste this for my next step so you can see. So I'm going to subtract 10y from both sides. So this side, positive 10y minus 10y cancels, and so it's gone on the left side. And then I'm subtracting 10y from both sides, so it's going to be subtracted 10y on the right side. Now that I have x equals something, I can take all of this and substitute it into the equation, the other equation. So I'm going to take our first equation and copy and paste it down here, and then take all of this and substitute it in for the x. Now what I like to do is I take this x right here and I always get rid of it, and then I put in parentheses for where the x was. That shows that all of what I'm putting in goes in for that substitution. So I just copied and pasted it in here. Now the next part is to multiply the 3 into both of these. To do that, I'm going to again copy and paste for my next step. 3 times negative 10 gives me negative 30y, and then 3 times negative 8 gives me negative 24. All right, so now I want to move further by combining my y's, and I can add negative 30y. I'm going to copy and paste for my next step. Positive 30y and minus 30y actually cancel out, so I'm going to delete this and delete this, and I end up with this weird looking negative 24 equals 60. So that actually, negative 24 does not equal 60. It will never equal 60. So this one here, because negative 24 will never, ever, ever equal 60, the answer to this is no solution. So what kind of a situation would we have where two equations will never have a solution, two linear equations? The case when that happens is if they will never ever intersect. which means that they are parallel. And this would be inconsistent, not independent. Or no solution, or you can say parallel. My fingers are too fast for my mouth. Parallel lines, and so forth. Those are all the answers. Okay, now I also said that I would go ahead and show you how I would do this by the elimination method. And just so that you can see, I'm also going to solve these both for y, so that you can indeed see that they have the same slope but different y-intercepts, which shows that they are parallel. So I'm going to take this one. Now, typically you should take the original, but where we're not going to be working with the fraction, I'm going to go ahead and take where I've already eliminated. But I am going to double check, because there are lots of times when a student or even the instructor may have made a mistake going from the step 1 to step 2 and go off of that, or even the typo. So I actually copied and pasted this over so I know this is not a typo. And same with this one, those aren't typos. So I'm going to just double check in here. 5 divided by 5 is gone. I get a 3. 5 times 6 is 30. 5 times 12 is 60. So this is indeed correct. But I'm going to copy and paste it down here for the elimination method. Okay, and then we're going to take this one and copy and paste it down here. Oops. There we go. And then I'm just going to pick one of these variables. It doesn't matter any of them. And I'm going to multiply it by something to match exactly the other equation's variable. So here I see I have a 3x and here I have an x. So the best thing here is to multiply this whole equation by 3, and not just make it perfect, but negative. So this is positive, so I'm going to multiply this entire equation by negative 3. And the reason I can do, or I'm doing that, is so that when I do that I can add these together and it will eliminate the variable x. So here I'm going to, for my next step, I'm going to copy and paste this and show the distributive. Negative 3 times, well, there's a 1 here, so that just makes it negative 3x. Then negative 3 times 10. Do not forget to multiply that into every single term. Negative 3 times positive 10 makes negative 30. Whoops, 30y. And negative 3 times negative 8 makes positive 24. Now the reason, so what I'm going to do next is I'm going to take these two equations and I'm going to add all of the terms from the first to all of the terms of the second, like so this, just like you did in like elementary school. In fact, I'm going to insert, let's see, I'll just underline. We'll underline this right here. Okay, so just like we did in like elementary school, and you have, I don't want that over there, bring it back. We have our two things lined up and we're going to add them together right on top of each other, like in previous little examples. And the reason I can do this, I can add the x's together and the y's and the right hand side, is that this, all of this does indeed equal this, and all of this equals this. So if I add these together, it will be equivalent or balanced, because this equal sign will equal these together. So when I'm adding these together, the negative 3x plus positive 3x is actually gone, so it's 0. And that's exactly what we wanted to do. Our goal was to get rid of a variable. So those give me 0. And we don't need the underline anymore. Get rid of that. Okay, in this case though, the negative 30 and positive 30 actually cancel out as well. So I end up with 0 plus 0 equals 60 plus 24 gives me 84. again, I end up with this really crazy, weird phenomenon, right? 0 equals 84, just like negative 24 equals 60. Those don't work. They will never be equal. So that leads me to the same answer of no solution. And the last thing I said was we can take these two equations and solve them for y to show that they indeed do have the exact same slope but different y-intercept, which would indicate that they are parallel, right? So we'll bring it down here. Okay, so the first one, let's continue solving this just as we started at the top. We'll just solve for y now. So I'm going to subtract 3x from both sides so that I can try and get y isolated on the left-hand side. Okay, so we'll subtract 3x, and that eliminates it on the right side. And this 60 is positive, so we'll put plus. Oops, I forgot the 3. Negative 3x. Okay, so we subtracted it, canceled it out on this side. Now the next thing I need to do is divide by the 30 so that the y can be isolated. Divide by 30, divide by 30, divide by 30, making sure that we do it to every single term. Now, again, for my next step, I'm going to show, copy, and paste. 30 divided by 30 is 1, or you can think of it as canceling out. Negative 3 divided by 30, both of those can be simplified by dividing by 3, so this is 1, and I'm just going to leave the x blank. 30 divided by 3, or simplified, gives me 10, or 3 over 30 simplifies to 1/10. Over here, 60 divided by 30 gives me positive 2. Okay, so now the next part is the second equation here, again continuing to solve for y. In this case, we'll just subtract the x over, copy, paste, x minus x, and if you want to write that in, minus x, you can do that so that on the left-hand side the x is gone. We don't need to show that that's positive anymore, it's just assumed, and the subtract x is over here. Now the next thing we need to do is divide by 10. Divide by 10, making sure that we do that to every single term. Divide by 10. Then to show my next step, I'm going to copy and paste. 10 divided by 10 is 1, or you can think of them as canceling out. 1 over 10 doesn't simplify, and 8 over 10 does simplify. I can divide both of those by 2, which gives me 4/5. There we go. Okay, so now this is my line in slope-intercept form. So I have a slope of negative 1/10. That means that I am rising, or in this case going down 1 and running 10, starting at the y-intercept of positive 2. Here I'm starting at the y-intercept of negative 4/5, but I have the exact same slope. So these two are in different starting places, but with the same slope. There's no way that these two lines can intersect, and therefore they are independent, or no solution, or parallel lines, however you want to write that. All right, I'm going to go ahead with problem number 2 in the next video.